Hello everyone. Today we are going to be looking at Chapter 2. Concepts will be intercepts of the graphs of equations. We're going to be looking at x and y intercepts. And then we will also talk about the solutions of the equations graphically and finding the points of intersections of two graphs. Let's start with intercepts. There are two kinds of intercepts, the x and the y intercepts. Now, the point a and 0 is called the x-intercept of the graph of an equation when it is a solution to the solution point of that equation. To find the x-intercept, we set y equal to 0 and solve the equation for x. So if we look at it from a graphical point of view, let's suppose this is my x and y plane. So this is x, this is y. And suppose this is the equation of a line. And we would like to know what is the x-intercept. So the x-intercept, guys, here would be this point. It will be the point A and 0. Now for the y-intercept, as is shown over here, it is the point here which the line crosses the y-axis. So this point is the y-intercept. So this would be the point, say, 0 and B. Now, the definition says the point 0B is called the y-intercept of the graph of an equation when it is a solution point of the equation. Now, to find the y-intercepts, we set x equal to 0 and then we solve the equation for y. Now let's go ahead and look at it from a graphical point. So over here we have 4 different graphs, and the first graph shows that there are 3 x-intercepts. So here's the x-intercept, 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 and only one y-intercept, and this is the y-intercept. So over here in the second graph, we only have the y-intercept. Whereas in the third graph, there are no intercepts. You can see the circle is crossing neither the y or the x-axis. Now, in the fourth graph, we have 2 y-intercepts. So this is intercept number 1 and intercept number 2 on the y-axis. And we have only one x-intercept. And that's the x-intercept is over here. Now, let's learn how to find these intercepts algebraically. So the example we are taking here is an equation given by 4x minus 3y equals to 12, and we'd like to find the x and the y intercepts of the graph of this equation. Now to find the x-intercept, we will put the y to be 0. So over here, so we will have 4x. Now remember, in place of y, we're going to put the 0 equals 12. And we're going to solve the equation for x. So what do we get? Say 4x equals 12 or x equals 3. So the x-intercept now here is given by the point 3 and 0. Very, very important to remember, guys, that the intercepts, they are points. Okay. And so they're represented by an ordered pair. Now let's look at the y-intercept. For the y-intercept, let's go down. Okay, so the y-intercept, once again, the equation is given to be 4x minus 3y equals 12. To find the y, remember we're going to put x to be 0. So over here, so when we solve this one, we will have 4 times 0 minus 3y equals 12. Or we get minus 3y equals 12. We can divide this by 3, negative 3 to solve for y. And what do we get? That y equals negative 4. Now remember, this is the y value for the y-intercept. The y-intercept is given by the point 0 and -4. Now, how do we show it graphically also? Notice the equation is 4x minus 3y equals to 12. This is an equation of a line. And in a line, to show the graph, we need 2 points. And we have got those 2 points. One is given by the x-intercept. Remember, the x-intercept is the point which is 3 and 0. Now we can draw it, eyeball it on this xy graph, and this is the point 3 and 0. Now remember, to draw this line, we need 2 points. One we have already got is the x-intercept. The next one would be the y-intercept, which is the point 0 and -4. Eyeball it over here. This is the point 0 and -4. Now simply draw a line passing through the points. Just draw a smooth line passing through it. So think of this one. Okay guys, it's a little off, so let me just erase this one, make a nicer one for you. Okay, so this is how we can draw and show the intercepts on the graph. Now the next thing we're going to look at is the zeros of the function. Now let's define what is a zero of a function. A zero of a function is a number such that, and it is a number here, a, such that f of a equals 0. So to find the zeros of a function, we only have to solve this equation fx equal to 0. Now the intercepts, specifically the x-intercept we just talked about, and zeros of the functions, they are very closely related. In fact, the statements are equivalent when a is a real number. So let's look at these statements which show that the connection of the zeros and the x-intercept. The first one, that the point a0 is an x-intercept of the graph of the function y equals fx. The same x-intercept, and only looking at the x-coordinate value, this number a is the zero of the function f. And also we say that the number a is a solution of the equation fx equal to 0. So now we are going to learn how to find the zeros of the function. Okay, now we go back to the same equation. To find the zeros of the function, there are 2 steps involved. First of all, we are going to write y equals f of x. So in other words, we are going to get y on the left-hand side and rest of the terms, x and the constant, on the right-hand side of this equal sign. So let's write this one. So here my y, what we are given. So we are given 4x minus 3y equals 12. Now let's get y on one side of this equal sign. So we will have minus 3y equals 12 minus 4x. You get the 4x over here. Now you divide by -3 and you get, so when you divide by -3, everything is going to be divided. What do we get? Y equals -4 plus 4 over 3 x. Now, this y is what we are going to write as. So this y, we're going to write this as f of x. So let me write this function here. So we get f of x equals -4 plus 4 over 3x. Remember, this negative and negative will cancel out, and that's why we get a positive here. Now, remember the question says find the zeros of the equation. So now to find the zeros, first of all, we wrote this equation as y equals fx, which is given by -4 plus 4/3 x. Now to find the zeros, we're going to put fx equal to 0. And we find x, or we solve for x. So let's go ahead. So we put fx to be 0. That is -4 plus 4 over 3x equals 0. Take the -4 on the right hand side. So that becomes +4 equals 4. Now we can cancel the 4's on both the sides of the sign. So let's go ahead, cancel 4 here. What are we left with? 1/3 x equals 1. And then we can multiply by the reciprocal of 1/3, which is, multiply this whole by the reciprocal of 1/3, which is a 3. So what do we get? 3 times 1/3 x equals 3. Or this 3 and 3 cancel out, and we get x to be 3. So clearly 3x equals to 3 is the zero of this function. Okay, now let's go ahead and look at another example. But in here, we will verify whether the zeros of fx are 0, when x is 0, or x is 3, or x is 6. So what we're basically going to do is we're going to plug in 0 in place of this wherever the x is given in this equation. And if the f of 0 and comes out to be 0, that means x equal to 0 is a 0 of the function. Similarly, for x equals 3 and 6. So let's go ahead and verify whether these 3 x values are the zeros of the function or not. So the first one is when x is 0. So the only thing you have to do is replace the x by a 0. So f of 0 is what? 0 cubed minus 9 times 0 square plus 18 times 0, which is basically a 0. So clearly, x equal to 0 is a 0 of the function f of x. Now let's test x equals 3. Now for x equal to 3, what you're going to do is replace. Now remember, once again, my function fx is given by x cubed minus 9x squared plus 18x. Now if x equal to 3 is a 0, then we have to check f of 3. If f of 3 is 0, that means yes, it is a 0 of the function. So let's go ahead and write f of 3 here. So let me erase this one. Now, wherever x is on the right hand side, replace it by 3. So you will have 3 cubed minus 9 times 3 square plus 18 times 3. When you plug the values in your calculators, you get 27 minus 81 plus 54. And you get the answer to be 0. So yes, x equal to 3 is a 0 of this function fx. Let's try the last one, which was given to us, x equal to 6. So once again, we are going to plug in. Let me once again write down. Fx is given to be x cubed minus 9x squared plus 18x. And I plug in f of 6. So when we do that, we get here on the right hand side 6 cubed minus 9 times 6 squared plus 18 times 6. We are getting the values to be 216 minus 324 plus 108. And we get that to be 0, 2. So all the three x values, that is 0, 3, and the 6, they are all zeros of the function f of x. Now we are going to look at points of intersection of the graph of the function. Now what do we mean by that? We say if you're given two equations, a point of intersection is an ordered pair which is a solution to these two different equations. For instance, in the figure given below, so I'm going to take you to the figure here, this graph represents the two equations y equals x plus 2, which is basically the equation of a line. So this is the graph we're talking about. And the second one is y equals x squared minus 2x minus 2. So both these graphs are represented on the same xy plane. And we like to know what is the point of intersection. So the first point we notice is the point 4 and 6, which is both on the line as well as on this parabola, which is the graph of a quadratic equation. Similarly, the point minus 1 and 1. So these 2 points are basically the points of intersection of these two graphs. Now that is if we can plot it in our graphing calculators and look at the answers. But suppose we want to solve it algebraically, how would we do about that? So let's go to this example, is finding the points of the intersection of the graphs. So first one, now I've taken another example. So these are two equations, y equals 6 plus 3x and y equals minus 1 and minus x. Both of them, if you notice, are two lines. And if we represent them graphically, this is what we see. Now, when we drew it on the graphing calculator, we found that both these points are meeting at this point given by minus 1.75 and 0.75. So this is a common point both to the line given by minus 1 minus x and sorry, this one is this line. I'm sorry, guys. This is minus 1 minus x. So this one is not the one. Sorry, this was a mistake. Okay, because remember, minus x means a line going down. So the blue line is representing y equals minus 1 minus x. And y plus equals 6 plus 3x is the red line. So these are two lines, and they're both meeting at the point minus 1.75 and 0.75. Now, how would we like to solve it algebraically? Let's move for that one. Now, in order to solve this algebraically, what we're going to do is, we're going to say let the first equation be 6y equals 6 plus 3x be equation 1. Second be minus 1 minus x. Now, if both of these equations, to find the point of intersection, there's going to be what we're going to do is, notice this equation 1 and equation 2. Because both of them are representing y, so that means when we solve these two equations together, we will get a common point where both of them actually intersect. So what we do is we write 6 plus 3x equals minus 1 minus x. Now let's solve this for x. Let's get x's on the left-hand side of the equal sign and the constants on the right-hand side. So what are we going to get? 3x plus x equals minus 1 minus 6. So we get 4x equals minus 7, or x equals minus 7 over 4, which is minus 1.75. Now remember, this is only giving us the x value of the point, and remember, point is an ordered pair. So to find the value for y, we can plug this minus 1.75 in any one of them. So let's plug it in to find y. So let's say y equals minus 1 minus x. We already have the x value. So minus 1 minus of minus 1.75, which gives us minus 1 plus 1.75, which is equal to 0.75. So the common point of intersection for both of these is minus 1.75 and 0.75. Clearly, this was one point we also got when we looked at from the graphically point of view. So remember minus 1.75 and 0.75? We can see it graphically, as well as that we can solve it using algebra. And here is our answer to it. Well, thank you, and I will see you later in my next video.